Okay, we had done these CP and CPK values before, and you calculated them previously. Now we're going to do confidence intervals for these. And on your, it's called your confidence intervals equation sheet. On page 3, it has equations for those. So like the first one here, we're going to do the first problem. Say this here. Tolerance for certain parts between 3.2 and 3.4. Sample standard deviation for the mean standard deviation is 3.1 and 0.05 based on sample size of 20. So the way we've been calculating the CP values, we've just gone ahead and used this equation before, but now we want to find the confidence interval for this. So first calculate your estimate the way we've done but previously. Upper specification limit, lower specification limit, divided by 6S. And so in this case, it's going to be 3.4 minus 3.2 divided by 6S. And S is 0.05. And so that's going to be your point estimate. And then what you're going to do, and then also when you get to the next one, we're going to calculate the same thing for CPK. So let's go ahead and do that. CPK. Would be the minimum of USL minus X hat 3S X bar minus LSL 3S. And so this is actually the same data as the first one. So that's going to be the minimum of the 3.4, excuse me, yeah, 3.4 minus the mean, 3.1, divided by 3 times 0.05. And then the 3.1 minus the lower specification, 3.2, divided by 3.05. And you'll calculate the minimum of those two. That'll give you CPK. And then we want to do confidence intervals for each of these. And so the confidence intervals, again, that's on page 3 of your confidence interval equation sheet. The CP is calculated with that chi value that we did last time. And you calculated several of these last time. And just use that times your estimate. And that's going to give your confidence interval. Now for the CPK, it's a bigger equation, but you use the Z values this time and find the confidence interval for there. So now when you're using this CPK confidence intervals, this Z values the regular confidence level, just the one that you've used before. Notice at the bottom there, it says that it's the confidence level ZC. In other words, you can find the confidence levels at the top of that equation sheet. Like here, you can see that the confidence levels, like 90%, The ZC is 1.645, 95%. The confidence level is 1.96. And it's just those regular Z values for the confidence level. You can do that. That'll be for the first assignment. And the next thing we're going to do is look at least squares. We're going to be curve fitting stuff. And let's go through some of that. Yeah, so then for this assignment, use this least squares equation sheet that I just gave you. Again, that's this equation sheet right here. And mainly we're going to use this like this front page, really. It's going to be the front page of this. And if you look at this little box here, we're actually doing the calculations. We're going to be focusing on like all the stuff to the left here. So let's actually go through this. So in other words, we're going to end up using this equation here and this equation here. That'll give us our slope. And then we'll, so we're going to need to fill in these columns. So let's go through a couple of these. We're going to say, so in this first one here, this is going to be x squared. So it's just going to be 1. And this is 3.2 squared. When I did that before, that was like 10.24. And then 19.36. 50.41. 94.09. So again, all I did was take the values in the X column and squared them and got these. And now for this column here, we want to take X times Y. So we'll take X times Y, and that's going to give us, so if we take this, obviously that's going to be negative 4.4. And these two will be 9.6. These two multiplied will be 25.52. These two will be 85.91. And these two will be 225.04. When you multiply those two together. And now, according to our equation sheet, we're going to also need the sum. Because we're going to, notice here, we're going to need the sum of the x squared columns. And actually, we're going to need the sum of the x column. And actually, down here, we're going to need the sum of the x column and the sum of the y and the sum of the xy column. So we would just have to add those up. And so if we do the sums over here, if we add that first x column, I did this before, is 25.4. Sum up the y column, 39.7. Next one is 175.1. And this is 341.67. So now we're going to go ahead and use this equation, these equations here, to find the equation for the best fit line. So again, we'll calculate this SXX and using the equation sheet. That's going to be summation of the XI's squared minus the summation of the XI's squared, the whole sum squared divided by n. And so let's see, xi is going to be 20, excuse me, xi squared is going to be this, is going to be 175.1. And then the sum of the x's is going to be this one over here, 25.4. Now that quantity's got to be squared. And that's over n. So n is the number of values we have here. So you can see that n is going to be 1. That's going to be n is going to be 5. And this is going to be 46.068. And again, according to our equation sheet, we're going to need this Sxy. Again, we can use this equation over here. Now, the only thing I just realized we're going to, no, okay, we don't need this yet. Yeah, Sxy, let me write that down. That's going to be the sum of the xi's, yi's, minus summation xi, summation yi, divided by n, and the sum of the xi's, yi's is going to be this one here. That's going to be our 341.67 minus the sum of the xi's times the sum of the yi's. And once again, n is 5. And when I calculated that, I got 140. And now we're also going to need, I just realized we're going to need X bar and Y bar. That's just going to be the average of the X's. So X bar, our total was 25.4. And we divide that by 5. And when I did that, that's about 5.08. And then the Y bar, gonna be this 39.7 divided by 5. And that's going to be about 7.94. That. The reason we needed that, we're going to use it here in a minute to find the y-intercept. So now we're going to find the slope. And if you look at, once again, if you look at your equation sheet, the slope is right here, Sxy divided by Sxx. So the slope, which also according to your equation sheet is m hat, is going to be Sxy, Sxx, and that's going to be 140 divided by 46.068. And that's about 3.04. And then the y-intercept is going to be, excuse me, yeah, y-intercept is that over here on your equation sheet right here. The y-intercept, calling it b hat. Yeah, y-intercept, which is b hat. And that's going to be y bar minus m hat times x hat, or x bar, I should say. And we calculate y bar up here, 7.94 minus x bar 3.04, x bar 5.08, and put that in your calculator. This comes out to be about minus 7.5032, like this. So then the equation of the line, which is also on your equation sheet here, that's this one like at the very top here. So now we've gotten all our stuff, we can plug it into this equation. So the equation of the best fit line is equal to mx plus b hat. And we found mx up here to be 3.04x. B hat was 7.5032. So the bottom line is then the equation of our line is going to be 3.04x minus 7.5032. That's our best fit line. Any questions on that? Now, the next thing that we're going to have to do, and you can do this part, is to calculate, like in this column here, you can calculate the estimated values based on the equation you have here. So, for example, for this first one here, we'll put in 1 into this equation and put 1 in there, and you'll end up getting this. Let's see, minus this comes out to be minus 4.46. Then you can calculate the next one, say it's 3.2. Put 3.2 into this equation here, and you get 2.225. Then put 4.4 into here, and you get 5.873. Then put 7.1 into this equation. You get 14.081. And put 9.7 in, and you get 21.985. And then next, we want to find like the error. And so we want to go through each one of these. And so like say, we're going to take your Y1 minus your value you got from your best fit line. And unfortunately, I don't think I have my calculator, but this is going to be, so this error rate here, this will be, actually, maybe put it right up here. Each EI will be your YI minus your f hat xi. So it's really just this column minus this column. Those are going to be your epsilon values here, your errors. And then you'll square those and sum those up. And you'll use all of that to find your variance using this equation here. So then finally, when you do, after you do that, you'll use the equation sheet again for part C, find the confidence interval for the point X equal 5 based on 90% confidence level. So in other words, you found the best fit line for the points you were given. Then the question is, how good is that line going to be so that if you pick another point that wasn't part of your data, what's the confidence interval for that? And that's given on the second side of your equation sheet. You're given this confidence interval here for the new observation. And so for this, you use the T table and use the degrees of freedom of n-2. And the same thing for part D. So you can go ahead and try that. Go ahead and finish that problem. And then when you're done, go ahead and do the back and do another one, which is very similar. Any questions on any of that? Yes, sir.
When we're doing the degrees of freedom, is the n just 5?
Yes. Yeah, good question. Yeah, that's exactly right. N is equal to 5 for the degrees we can do the degrees of freedom. And then like here, you take 2 away, so you end up using 3. Yep, good question. Any other questions?
I had a question about the equation sheet for the confidence intervals of process capability. What would alpha stand for?
Yeah, so alpha,
I'm sorry. What is it again? Squared,
let's see.
the top part. Yeah.
Oh, this here? Yeah, that was from the stuff we did last week from our, yeah, from this chart here. And then the next one, this confidence interval uses the Z chart.
Okay.
Any other questions anyone can think of?